Okay, this last video will walk us through the last problem here of Lab 1, the fourth and final problem. This one's actually, I think, the easiest problem to do in terms of the math, but it's the one that involves the most tricks to Excel that you may not be familiar with. So this one says if you do the previous problem correctly, you should get a peak height for the jump of y2 being 1.29 meters. And after you get to that peak height, then you still need to fall back to the ground and land on the ground to complete the jump. And so the spreadsheet here, if you go to page 2 of the spreadsheet, which has the data for problem 4, gives you in column B here the height of the center of mass of this athlete as they're falling from the peak until they get down to the bottom here and finish the jump. Okay? And then within there, it's got their position measured every 10 milliseconds or every 0.01 seconds while they're falling. And so we're asked from that position data as a function of time to calculate their velocity as a function of time. And to do that, we're told to use equation 111 here. Let's go back and review what that was. And that's this equation here. This equation is known as the central difference formula. It's a way of estimating the derivative of a variable. And I say estimating because this is going to end up giving us a numerical estimate of what the athlete's actual velocity is. It's not going to be their real, true, actual velocity, even if we have like perfectly accurate measurements of their position here, hypothetically. This is a numerical estimate of the velocity. But if we measure the position accurately and measure it at very closely spaced points in time, this is generally a very accurate estimate of the derivative of position with respect to time, which of course is our velocity. Okay, one thing that I hope you will take away from or start taking away from this particular problem is a way of reading equations like this, like equation 111 here, written in the language of math and understanding what it's saying in the language of English. And so to help you with that, let me describe this equation to you in terms of what it's saying in English. So like I said, this is a way of estimating velocity v from position x and time t. And how do we do that? This is something we would do when we have a variable like position here in column B measured at a bunch of different intervals of time during a movement in column A there. And from that I can estimate the derivative of this variable with respect to this variable, which in this case would give me velocity. Velocity is the derivative of position with respect to time. Now, what is this equation saying in practice? What is it actually doing? This is saying I want to know the velocity v at some time t, and I'm going to calculate that by taking the position at some time a little bit into the future from the time that I want to know the velocity at. So I'm going to go to my time t, and I'm going to jump forward in time by some small amount delta t. Okay? And then I'm going to grab the position that I measured at that little increment in, a little bit into the future in time. Okay? And so that's what x as a function of t plus delta t here is saying. It's saying that is my position measured a short little step into the future from the time that I want to know the velocity at. Okay? So then I'm going to take that future position and I'm going to subtract from it a past position, or a position measured at t minus delta t, or at some small step in time into the past of the time that I actually want to know the velocity at. Okay, so I'm going to take my future position, I'm going to subtract from it my past position, and I'm going to divide by the gap in time that happened between those two measurements, which if I'm one time step into the future and then one time step into the past, that's a gap in time of 2 total time steps that happened between my measurements there, so 2 delta t there. Okay. Now, what is delta t for this problem? If I go to my sheet here and just go down the time column there, you can see each time I take a measurement of my position, my time increments up by 10 milliseconds or 0.01 seconds. It starts at 0 and then goes up to 0.01, 0.02, 0.03, 0.04. So my time step here is 0.01 seconds. So the gap in time between any 2 consecutive frames is 0.01 seconds. That's my value for delta t there. Now we're asked to do this calculation of velocity at all of these same points in time for the position here, the same points in time that we have position measured at, except we're not doing it for the first time point or for the last time point. And you'll see why that is if I do just one sample calculation here. Hopefully you'll see why that is. So let's do it at my first box here where I'm asking you to calculate velocity, and then that'll maybe make it clear why we're not asking you to calculate it at the first one or at the last one. So I want to know my velocity at time 0.01. So to do that, to implement equation 111 here, I'm going to take my position, that's one time step in the future from 0.01 seconds, which would be my position at 0.02 seconds. So cell B4 there. And then I'm going to subtract from that my position that's one time step in the past from the time that I want to know my velocity at. So one time step in the past from 0.01 seconds is 0 seconds, and that's column B2 there. Okay. And then I'm going to divide that difference, my future position minus my past position. I'm going to divide it by the gap in time that happened between those two position measurements, and that's my 0.01 seconds, my time step there. Okay. And that gets me a velocity of about negative 0.1 meters per second for that particular point in time. Okay, now what would happen if I try to do that calculation here at my first time step, at time 0.00? I would say, okay, I need my position one time step into the future, and then I need to subtract from that one time step into the past, but I don't have a time step into the past. My 0 seconds is my first time step, so there's no past information. There is a way that we can still estimate velocity here. We can just take our future time step, or our future position, sorry, and subtract from it our current position, and then divide that difference by the gap in time that happened in between there, which was only one time step. We only went through, one time step going from my current position to my future position. And there we still get an estimate of my velocity. This isn't as accurate of an estimate of velocity as what I was making up here, because it's not using any past information. It's just using future information and current information, and that ends up being a little bit less accurate for estimates like this. But to avoid having to have you use different equations and keep all that straight, we're just going to ignore our first time step here. And same story if I got down to the bottom here, and I was trying to calculate my velocity here at my last time step, I would say, okay, I'm going to take my position one time step into the future, and oh, I don't have a time step into the future. All I've got is my current position and past positions. So I could do a similar thing here. I could say, all right, I'm going to take my current position, and I'm going to subtract from it my past position. And since there's only one time step that happened in between there, I'll divide that by just one delta t, and then I get an estimate there. But it's not as accurate of an estimate as we would be making if we had some future information beyond there, which we don't have. So just to keep things simple and to do the most accurate calculations and to just use the same type of equation for all of these, we're just going to calculate it at all the intermediate time steps. We're not going to do it for the first one or for the last one. Okay, so let's just repeat this just so everyone can see again what we're doing here. We're going to take our position one step in the future. We're going to subtract our position one step in the past. And we're going to divide that by the amount of time that elapsed between those two measurements, which is 2 time steps here. And there's our 0.0981. Okay, then I want to do that for this next time point here at 0.02 seconds. I want to calculate my velocity. So I can do equals and take my position one step in the future, subtract my position one step in the past, again divide by 2 delta t, and there's my next velocity. And I could keep doing that, typing that in by hand for the velocity at 0.03 seconds, 0.04 seconds, 0.05 seconds. That would take me quite a while to keep typing all that in by hand for all of those different velocities there. That'd take me a little bit of time to keep typing that in, to keep repeatedly doing this same calculation, just referencing cells in different positions every single time I wanted to do it. Isn't there a quicker way of doing this? There is indeed a quicker way of doing this, and I will show it to you here. So let's start from scratch here again. I'm going to say I want to take my future position minus my past position, and then I want to divide by 2 time steps. Okay. Now, let's suppose I want to do that same calculation down here for my next point in time, but I know I just want to grab my future position, my past position, and my time step. What happens if I just copy what's in cell B3 there and just paste it in to cell B4? Well, I got something, but I didn't get a number. And let's see what's actually going on here. So if I double click on my formula there in my cell, it'll show me what it's doing. And it's grabbing my future position, so that's good, that's what I want. And it's subtracting from it my past position, that's good. But then it's dividing it by 2 times cell F2 here, which doesn't have anything in it. And so that's why it's given me this result of divide by 0 there. If there's no number in here in cell F2, it's just assuming, well, that must be 0. And when you divide by 0, that's generally not a good thing to do in mathematics. You don't get a sensible result there. If I punched in 0.01 seconds here, then I would get a numerical result and the correct result for that particular velocity. Okay, so I could just keep, and then if I copy this down to my next one, I'll again get divide by 0, and I'll see, oh, it's grabbing the next position and the past position, but then again, it's expecting my time step to be down here, and I don't have anything there. So I can punch that in, and then I get it again. So, maybe I just punch in all my time steps here. That's kind of annoying. I don't want to have to do that. Can't I just tell it always divide by the value that's in cell F1 here? You can. And how do we do that? If I go back to my original formula, I say take the future position, subtract the past position, divide by double the time step. But then I want to tell it, okay, when you're dividing by double the time step, no matter which positions you're grabbing over here, always go to cell F1 and grab that time step. So how do I get it to always reference that time step? You go to here, to your formula bar, and you put a $sign in front of the F and a $sign in front of the 1. Okay. So what that's doing is when I copy this down, it's referencing that formula in a positional sense. It's looking at it in cell C3 here and saying, you were grabbing a value that's 1 row to the left, sorry, 1 column to the left, and 1 row down, and subtracting from it the cell that's 1 column to the left and 1 row up. And it's also doing that here. It's grabbing 1 column into the future, sorry, 1 row into the future, and 1 column in the past. But then since I put those $signs there, it's still referencing cell F1. It's not incrementing that downward like it was without those $signs. Okay? So this is telling it, no matter where I put this formula, to grab the future position, subtract the past position, and divide by 2 times whatever's in cell F1. Okay, so I could copy paste that down, manually. And that's quicker. I don't have, that's a lot quicker than typing it in by hand, but it's still kind of slow there. Is there a quicker way, if I just delete all these extra ones out, is there a quicker way to just get it to quickly fill in that formula into all these other yellow cells there? There is. If you go to your cell, when you've got it selected here, and grab this little square in the lower right corner, and click and hold on it, or tap and hold on it if you're on a tablet or something, then you can drag it down. If you see my box increasing in size there, drag it down and highlight all the cells that you want it to copy into, and then let it go, and then it'll automatically copy that formula into all those cells that you highlighted there. Another thing you can do, if I undo that there, is if you click on that cell and then double click on that little box in the lower right, it'll automatically paste it in down there all the way to the bottom. Now Excel kind of tries to outsmart you a little bit here. It'll look at the column that you're pasting it into there, and it'll copy it down anywhere that there's a number here on the left hand side. So it did it here for this this last one here, and since we don't have our future information there, it's referencing a value of 0 there that it doesn't know about, and so we want to delete that one. But other than that, it's successfully copied and applied that formula to every one of these cells there. Okay, so that's an important trick that you'll want to use in Excel when you have like columns of data that you want to repeatedly do similar calculations in here. Say you had like 100 of those to do, which won't be unusual in some of the problems we'll do in this class. It'll take you a long time to punch all those in by hand. A lot of chances to click on the wrong thing, a lot of chances to not have it referenced right. If you just do it this way, where you type it once in the first cell and then automatically fill it in to all the other cells in that column, that'll save you a great deal of time, and it'll help you make less mistakes by only having to enter that formula in one time. Okay, so that gives us all of our velocities. Let's set them to a good number of digits there. Let's give them 2, since our positions had 2. And then we were also asked, I believe, to make a graph of velocity versus time. And so let me walk you through how you make a scatter plot here to graph data like this. If I have one column of data like time, and I want to plot that on the x-axis with another column of data like velocity on the y-axis, how do I do that? Let's make my field a little bigger here. Okay. There's a couple ways you can do it. This is the way I do it. You may know of or find different ways of doing this in Excel. But I'm going to highlight all of my time data. And then I'm also going to highlight all of my velocity data. And then I can go to Insert, Chart, and I want to do an XY plot or a scatter plot. This is a plot if you have like some discrete numerical values and another column of other discrete numerical values, and you want to plot the first column on the y or x-axis and the second column on the x-axis. Or sorry, the first column on the x-axis and the second column on the y-axis. That's what this is going to do here. Okay, so that gives me my time on the x-axis and my velocity on the y-axis. And this is kind of an ugly chart. This is not a very good looking chart. This is not the kind of thing we would want to put into our lab reports. We'd want to make it a little bit more clear and a little bit more obvious what is happening here exactly. So how should we pretty up our charts here and make it a little bit more clear and obvious what this is actually showing? I'm going to delete my title there. And first and foremost here, I want to get some labels on these axes. I want to tell my reader what variable is plotted here on the x-axis and what's plotted on the y-axis. And how do I do that? If I'm under chart design here, under my tools, I can go to add chart element, axes titles, and I can add a primary horizontal title, and I can add a primary vertical title. And then I can click on that text and type in what actually is plotted on those axes. And you'll generally want to tell your reader what is the variable, and then in parentheses, what are its units. So that's time in seconds. And then same thing for the y-axis. This is velocity in meters per second. Okay. Excel defaults to this kind of tiny font and this kind of gray color for it, which I don't really like. And so I like to make that a little bit more clear to my reader. So if I go to Home, I can go to the text color here, or the font color, and change that to black. Makes it a little bit darker. I can click on my titles there and make them bold, just with Command B. And then if I click on the whole thing, like just anywhere on that white background there, and then I can change the font to, let's try making it 14. And just make a little bit bigger there. Looks like it when it changed the font, it got rid of my bold, so let's get that back. Okay. Now, what else might you want to change here to make this graph a little bit prettier? This looks kind of weird, having the x-axis at the top there. That's kind of strange. Why is it doing that? Excel will, by default, assume that you want your axes plotted starting from this 0, 0 point, which will normally look okay for most data. Where it's something like this, where the y-axis is always negative, then it ends up looking a little strange. We might think we might want the labels like down here at the bottom somewhere, right? So how do we get that? Let's click on my vertical axis here. And then if I click on Format, and then Format Pane, if I look at what options I can pick here, you can see there's one that says Horizontal Axis Crosses At. Then if I click on axis value there, and then whatever number I punch in here will be the number on this y-axis where the x-axis connects to that y-axis. So right now it says 0, so my x-axis connects to my y-axis at 0. If I make that -2 and push return, then they cross at -2. And if I make it -4.5, then they cross it at -4.5 down there. Okay. And that makes it look a little bit more like the XY plot or the scatter plot that I might typically be used to seeing. Okay. In those axis options, so if I go back to that format that I had there, if I click on my y-axis, I've still got my format pane open here, I can change like the bounds on those variables. If I want it to graph a different range here, I can say, okay, what's the max range on the y-axis and the minimum range. I can change the units, like the intervals at which it plots values there if you want to change that. You can again change where it crosses at. You can change what the tick marks look like. You can change the format and style of the number, like if you only want it to show 1 decimal place, for example, you can change that. If you want to change like what the data look like what this plot looks like, that you do a similar thing. You just click on the data. And then if I go over here to the paint can, then I can change some things about what that line looks like if I want to have a line showing my data, which I don't have right now. But let's suppose I click on solid line. Then that connected my data points with a line there. And then you can also change what the marker, what the symbol looks like. You can change, if I go to built-in, I can make it X's if I want instead of boxes. I can make it circles. I can make them bigger if I want. If I don't want any symbols, then I can say none, and then I just get a line. If I go back to the line, I can change some things about it. If I change the width here, I can make it thicker. If I want it to be a dashed line or a dotted line, you can make all sorts of changes like that. So all sorts of options in there for visually what you want your graphs of your data to look like. And there is some other options in there I didn't really go over, but you can change, the color of the line, like if you want it to be orange or whatever. All sorts of things you can change here about what your data actually look like in your plots. Generally, and if I pull this up again, so let's just make my plot again here. Time, velocity, insert chart, scatter. So this one up here, this first one I made, to me is a lot cleaner and a lot more easy to tell what I'm actually looking at than this one down here, this kind of default one. Okay? So you're rarely, if ever, going to want to just roll with whatever the default chart looks like here when you make a plot like this in Excel. You're at a minimum going to always want to label your axes, tell the reader what variable is plotted on which axis and what the units are, and you're going to want to play around with what your line of data or your columns of data look like. So give them some attractive colors, give it a line that shows the data for a scatter plot typically instead of symbols. Things like that can make a big difference in how easy it is for the reader to understand what your plots look like and what's actually shown in those data. Okay, that is it for this problem, and that is it for the 4 problems for this lab.